Welcome to this course aiming at providing you with a practical view on code sharing. It has been developed as part of DATAMIND, the UK Health Data Research Hub for mental health, and in collaboration with the University of York via Project SPORE. I am Dr. Marcos del Pozo Banos, Senior Lecturer at Swansea University Medical School as of the time of recording, which is September 2023. And I will try to convey to you some of the things I have learned over the 15 years of experience I have writing production-ready code, predominantly in Matlab, R, and Python. I hope you enjoy the course, and please do not hesitate to reach out with any questions or feedback at datamind@swansea.ac.uk. Why should you consider sharing your code? Whether your code constitutes an app, a library, or a research project, the obvious answer is that sharing your code increases the chance of other people using it. But it also lowers the barriers for having contributions and collaborations. Mostly because once your code is publicly available, many of the legal hassles around co-production disappear, especially if you're working with the private sector. At a community level, code sharing allows upcycling and remixing existing code, including improvement and reuse of code, even for purposes other than the original. And no doubt, it helps with transparency. This is particularly key for research reproducibility and repeatability. We can see the source code as a fully detailed description of the research methodology. Should you fully share your code with the public? Even in academia, publications aren't everything, and there might be incompatible future plans for the project. For example, the creation of a spin-off whose product or service is based on the developed code. Also, not all partners may be willing to make the code open, particularly if they are from the private sector. As a rule, remember to double-check with your institution and with all your partners before you make any of your code public. You have decided to make your code publicly available, and you have the green light from your institution and your partners. Now, it may not be clear when you should do this. Following the rules of open science to the book, you make it public the moment the idea is formed. Certainly, if you hope to engage with the community and get them to contribute, you will need to share your code while it's still a work in progress. Alternatively, if you are developing the code on your own or with a predefined set of contributors, you may want to wait until the code is fully functioning. In academia, you may want to wait a bit longer until the paper is submitted or published. And in the private sector, you may be required to wait a certain period of time, for example, until a certain profit has been made from it. As a practical note, remember that when you make your code public, your work and programming skills will be there for everyone to see. This will get the best out of you, but you may want to give yourself time to polish your work before publishing it, especially if you are not proficient in writing code. In your code sharing plans, you should consider who you will be sharing it with. The first group of people will be the expected contributors. These may be people in your team or organization, but it may also be external collaborators. You may also share your code with some or all of the stakeholders. Even if they are not directly involved in writing the code, they may be interested in checking progress for themselves. Of course, you can also share the code with the public in general. This is what the rules of open research stipulate, and therefore has all the advantages of open research, such as full transparency. In any case, note that the whom may depend on the when, and so you may want to share your code with collaborators during development, with stakeholders during reporting, and with the public in general once the project is completed. Deciding that you are going to share your code, when you're going to share it, and with whom is just the first step in the process. Next, you need to decide how are you going to enact this plan. Things to consider are the tool, which is commonly a version control tool, the code license to legally regulate how others can interact with your code, the contributing guidelines to stipulate how contributors should help with its development, the documentation to guide users in using your code, the discoverability to help people find your code, and the code maintenance plan to keep your code working properly and up to date over time. Typically used tools for code sharing are GitHub, GitLab, which is an open source software version of GitHub, and so it complies with open science principles, Bitbucket, and SourceForge. These are all very similar, and which one to use depends on a specific project needs. However, for typical research projects in academia, GitHub or GitLab are usually good choices with suitable free plans. The subject of code licensing is large enough to cover a whole course on itself. We'll just graze its surface here. There are three main categories of open code licenses: copyleft, permissive, and Creative Commons. Copyleft are often referred to as viral licenses, as they require at least the same level of openness in anything that uses your code, although there are different levels of virality. The key thing to keep in mind is that they may introduce legal incompatibilities with other projects. For example, a project interested in using your copyleft licensed code may not be able to do so if it also relies on code with a more restrictive license. Permissive, as their name suggests, are more relaxed licenses, and they pretty much let users do whatever they want with your code, with some interesting boundaries, such as patenting and trademark rules. The most popular in this group is the MIT license. Creative Commons is a modular type of license, which allows you to add only the coverage you need for your code, so it's quite flexible. Although in reality, there is nothing stopping you from modifying an existing license from any of the three categories to meet your needs, Creative Commons simplifies this by having modularity built at its core. You may also be interested in keeping ownership of your intellectual property. A patent can help you protect the factual aspects of software, what it does and how it does it. This includes procedures, algorithms, and ideas. Software copyright, on the other hand, can be used to protect the artistic side of your code. In the UK, you automatically gain the copyright of things you publish, but remember that these rules are not universal. Regardless of what your licensing, patenting, and copywriting intentions are, there are three key points to remember. First, you must check with your employer before applying any licensing, patenting, or copywriting to your code, as you may be unintentionally breaching your contract. Second, and in relation to licensing, remember that the most important goal here is to legally protect yourself against liability. And third, all this legal hassle helps, but does not guarantee that you will get attributed for your work. And this is crucial in academia. You should consider getting a DOI for your code, and GitHub can help with that. Also consider publishing your code on specialized journals, such as the Journal of Open Research Software, and adding text in key documents, such as the documentation or even the license, reminding others of the scientific referencing rules and providing the citation to use. Documenting your code is important regardless of your sharing plans, but it's critical if you are sharing your code. But how far should you go? If you're just sharing with other developers, a technical documentation may be enough. While if you're making your code publicly available, the documentation should be more narrative to facilitate readability, and it should provide context and detailed explanations of what your code does. If what you're sharing is a tool, you should provide clear instructions of how to use it. Documenting your code can take up a large chunk of your time, so you should carefully consider what level of documentation is necessary, normally based on who you will be sharing your code with. Code writing is a creative process, and as such, it's bound to be messy. However, it's on your best interest to dedicate some effort to limit the level of messiness. More so if you are collaborating with others in the code development process. Contributing guidelines set rules for developers in your project. These typically specify things like folder structure, coding style, naming conventions, supported file types, and documenting requirements. When writing this, it's best to abide to community standards from your field if there are any. Devising and writing contributing guidelines can be time consuming, but it's an exercise that will definitely pay you back, especially if your team of collaborators is large. Code sharing is pointless if people can't find your code. As the basis for discoverability, ensure that you have a persistent URL for your code. Version controls tools such as GitHub will provide this. Having a DOI is also interesting, especially when citing your code in text documents. Services like Zenodo or Figshare can help you with this. Zenodo is even integrated with version control tools to simplify the process. Finally, dedicate some time to disseminate your code through the right channels, social media, journals, etc. If there are any dedicated repositories in your field, make sure to use them. For example, if your code represents an algorithm to identify health events from routinely collected healthcare data, the HDR UK phenotype library will be a good place to disseminate your work. A piece of software is rarely static. Even if free of bugs and without further development, updates on the tools your code relies on may actually break it, and forcing users to install a very old version of these tools may be unreasonable. If you want your code to stand the pass of time, you need to be ready to put some effort to ensure so. Aside from this, and depending on the size of your project, your code is likely to have bugs. As a user, few things are more frustrating than a piece of software that doesn't work. As a developer, no one wants their name associated with broken code. So developing a battery of tests to check the correct functioning of your code is highly recommended when publishing it. But even so, some bugs will likely remain hidden to you and to your team, while users are experts in finding them. You need to be ready to provide support and resolve issues in a timely manner. If your code defines a tool, you may also want to consider plans for improvements and growing, especially if based on feedback from users. Overall, keep in mind that making your code public may push the end date of your project past the completion date of the first version. With this, we've reached the end of this course. I hope you enjoyed it and that you find the information interesting. Let me highlight some key messages that I would like you to take away. Code sharing has important benefits for the community and for yourself, but it doesn't fit all projects equally. Being flexible to details like when and with whom you will share your code will allow you to adapt the process to your situation and needs. In terms of implementation, GitHub is usually a convenient tool, and MIT a commonly used license. Remember to set aside time for writing documentation and contributing guidelines, and to think a strategy to maximize your code's discoverability. Finally, consider whether your work is done once the code is completed, or if you need to maintain certain aspects of it over a period of time. All of these will directly impact the duration and cost of your project and should be decided in the planning stage. Consider the amount of time and effort necessary to make your code open and the associated overheads. Weigh the costs against the potential benefits in quality, long-term productivity, especially if reusing the code in the future, ownership, and uptake when making these decisions.